Okay, we begin with the worksheet on binary probabilities. I gave the class time to do the first 4 questions, and if you haven't done those, you should do so before you look at what we're doing. In any case, okay, first question asks you to list the number of outcomes, or list the outcomes for flipping a coin twice. Now, I'm assuming everybody knows how to do that. That's been done several times. Heads, 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 tails, tails, heads, tails, tails, corresponding to the tree. You would get, if you put heads this way, tails this way, then off of this heads, you put a head and a tail, and off of this tail, you put a head and a tail. You get this order of listing. Now, if you then go to the end of each one of those sequences and put a head and a tail on it, you get another listing, and the same if you add another coin. So the outcomes for flipping one coin, though, are these. Now, to get the outcomes, to just list the outcomes for 2 coins, of course, most people in class sketched a tree diagram, and that's perfectly valid. But if you sketch a tree diagram, you're going to get the same thing that we get with the listing, and I'm going to stick to a listing here. Not that that's necessarily preferable, it's just that's the way I want to do this to illustrate this way of doing things. Okay, so what I do to get the number list the outcomes for flipping 3 coins. First, I list the outcomes for flipping 2 coins, and then I list them again. Now, what I then do is I put a head in front of each of these in the first listing, which gives me all the possibilities for 3 coins if head comes first. And then I do the same thing for the second listing, except I put a tail on it, and that gives me all the possibilities for flipping 3 coins if tails comes first. Now, either heads is going to come first or tails is going to come first. This means that I've got all the possible outcomes for flipping 3 coins. Okay, now to get the outcomes for flipping 4 coins, I list the outcomes for flipping 3 coins. Okay, I've got them listed here. Ignore the circles for the moment, and then I list them again. Okay, so I've got 2 listings for the things that can happen to 3 coins. Now, if I put a head in front of my first list, then I've got all the possibilities that could occur if I flip 4 coins and get a head first. If I put a tail in front of each of these, I get all the possibilities that can occur if a tail comes first. So I see that if I count the number of possible outcomes, I've got 4 possible outcomes for flipping 2 coins. Then I'm going to double that. Remember what I did was I listed the 2 coin possibilities twice, put head in front of one listing, tail in front of another. That doubles my number of possibilities, and I get 8. And then, of course, I list all those possibilities, put head in front of one part of one list, tail in front of the other. That again doubles the number of possibilities. So we can see how the number of possibilities continues to double. Okay. We can now easily answer the question of how many of your outcomes for flipping 4 coins have exactly 2 heads. And I guess I should put the word exactly in there. Well, I can easily figure that out. I just go through here and find the outcomes that have 2 heads, exactly 2 heads, and circle them, and then count them. I've got 1, 2, 3, 4, 5, 6. I can double check, make sure that none of my other outcomes have exactly 2 heads, and I come out with an answer. Okay, and now I'm going to note that 6 equals 4C2. How can we correlate this 6 that I get by listening and counting the outcomes that have exactly 2 heads? How can I correlate that with combinations? Is that just a coincidence, or does that have some meaning? Well, let's think about it. I've got 4 slots here. Okay, I'm going to fill each slot with a head or a tail. There's 16 different ways to do that, and only 6 of them have exactly 2 heads. why is it that only 6 of them have exactly 2 heads? Well, there are 4 slots, and I want to pick exactly 2 of those to fill with a head. So I could put a head here and here, here and here, 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 or here, here. And of course, I could do that in a different order. Instead of here and here, I could go here and here, but it would be exactly the same. I'd still have heads in both of those places. So any choice of the 2 slots in which I could get the 2 heads could be listed in 2 different orders, here and here versus here, then here. Okay, so filling those slots is equivalent to just picking 2 slots out of the 4 where order doesn't matter. I picked 2 slots out of 4. How many ways are there to do that? Well, there are 4C2 ways to do that, because 4C2 is exactly the number of ways of picking 2 things out of 4 where order doesn't matter. So that's the connection between the 4C2 and the 6 that we got from the listing. We could have reasoned that out just using the concept of combinations. And that, of course, would be pretty handy if we wanted to fill 7 slots. Okay, if we had 7 coins to flip, which is the next question. Okay, there's 7 coins, and we want to know how many ways there are to get exactly 3 heads. So you might want to think through that. We're going to pick that up in the next video clip. This one's getting long enough.